I'm starting repair on this Yamaha P5000S amplifier. It does absolutely nothing when you turn it on. It's just completely dead. The fuse is not blown. And I've printed up a couple pages from the service manual here, which are pretty hard to read because of the broken English. Repair concrete instance at the trouble part. All secondary output isn't output. And it's got a lot of things to check, and so far what I've found is that the two main switching transistors are shorted, Q406 and 407, so I'm going to have to get a pair of those ordered in. And among other things, I imagine there's some bad resistors and possibly the chip that controls the switching transistors. So I'm going to poke around and see what else is bad and get these unsoldered, and I'll get some parts ordered, and we'll continue the repair from there. Continuing the work on this, I've already written down what needs to be replaced, and now I'm checking capacitors. I've already found a few bad ones. I'll show you some examples. These ones around here I've checked so far, but this is what I use for testing my capacitors. This is called an ESR meter. This particular one is made by Electronic Design Specialists, and I think it's called the EDS 88A Cap Analyzer Series 2. Very, very useful tool. I use it all the time when I'm troubleshooting things. And so I'll show you a couple examples of how this works. There's basically a chart on here for a given capacitor value. It goes from 0.47 microfarads all the way up to 2200 microfarads. And you can test higher, but you'll just go off the chart. So I'm going to put the tester on one of these 10 microfarad capacitors that are right in this area here, and I'll show you what the scale says. So see if I can find that one again. Actually, what is this capacitor? This is a 100 microfarad capacitor here. And that is most definitely bad. It is not even reading good for a 2.2 microfarad. So that's just one example. I'll check one of these larger 470 microfarad caps that are right here, and just out of curiosity, and see what these say. That one's still good. How about this one? Doesn't surprise me that these are good, because these are Nichicon capacitors, and they are the PW series, which I really like. Those rarely fail. These cheaper ones are Samsung brand, and which aren't really bad, but these caps are only rated at 85 degrees, and I don't like to use 85 degree general purpose caps in professional electronics like this, so I'm going to be replacing all of these caps with Nichicon PW high temperature low impedance caps that are rated for power supply duty specifically. So I'm going to go through and test the rest of these. Any of them that are bad, of course I got to take note of that, and if I don't have it in my stock, then I'm going to order those in. These large transistors here are actually IGBTs, and they're about $8 a piece, and hopefully they're not going to blow again once I replace everything. But I've also got to replace both these chips here, and the caps, and possibly this voltage regulator. It's a regular old 7815A voltage regulator. The resistors don't look too bad, but there's a couple that are a little bit higher than I'd like them to be, so I'm going to go ahead and replace those too. Everything is in this. Whoops, my camera is set to manual mode. Here we go. Even though this list is a little bit difficult to follow, all the component values are in here. All the resistors are 1/4 watt, 5%, from what I can tell, except for the ones that are larger, like the 5 watt. And I'm going to get these parts. It looks like Mauser Electronics, which I usually get my parts from, has all this stuff in stock. So I will get this stuff ordered and hope for the best when I get the new parts installed. As soon as everything gets here, we'll move on to the next segment. Well, I've checked all the caps on the board, and the sad thing is, the only ones that are within spec are the Nichicon caps, and maybe one or two of these kind of larger, I think they're Noya brand caps. I couldn't quite read them. Those are kind of marginal, but not what I would call bad. I'm going to replace them though regardless. But all of these smaller caps, all the Samsung caps, are all out of spec. Some of them are in the yellow, and a lot of them are way down in the red. So I've definitely got my work cut out for me with replacing caps. And that bugs me because that means more than likely the caps are bad on the output modules as well. And even though there's only a few of them, they're going to be really difficult to get to because, you know, obviously the heatsink is in the way. And rather than unsolder every transistor and other thing that's attached to the heatsink, I'm just going to have to unscrew. I forgot to turn my meter off. I'm going to have to unscrew everything off the heatsinks, and there's a line of transistors down both sides. You can't see the ones that are on the opposite side, but there's a lot of them. So that's going to be a lot of work physically to get to those caps and get those changed. But I think as long as the transformer's not bad or any other blah 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 other unique part, this should fire up and work just fine after everything gets replaced. We can only hope. Alright, it's about 4:30 in the afternoon on Thanksgiving Day, and I finally have enough free time to work on this amp again. All my new parts came in the other day, and I can finally get started. First thing I'm going to do is replace all the bad caps on this board and get that out of the way, because that's the bulk of the labor. And then after that I'll take care of the IGBTs and the chips and the regulator if it needs to be changed. So I've got the soldering equipment ready. I'm going to get these caps out of the way and do the next step after I'm done. Moving right along, I've got all the bad caps changed, plus the two chips here, the two resistors that were open. You can see those are a different style, but same rating as the original. The original style was a ceramic encased resistor, and I could not find these anywhere, so I just had to get what I could find that would work. All I got to do is wait for my soldering gun to cool down enough that I can change the tip over to the larger diameter one, which will allow me to unsolder these IGBTs down here and get those changed. And then just follow the testing procedure in the service manual here to make sure that the proper waveform is going to the IGBTs before installing this fuse. And if all that passes, then I can put the fuse in, hook up the dummy load, and test this outside of the amplifier to make sure it's running correctly. And if that's good, then I can reinstall it. I've got the new IGBTs in place. I think the hardest part was getting the old heatsink grease off so I could put the fresh stuff on, because that stuff was really solidified, and I had to like scrape it off with a plastic scraper and be really careful not to break the mica insulators. And this one actually had two thin insulators and this one had one thick one, so it was like this one I had to really be careful. But they're on there. I ended up removing this filter cap so I could get my screwdriver on this one easier. The cap kind of blocks it. So I'm going to put this cap back on, and I can proceed with the first test of the driver circuit down here. Everything's back together, and I'm getting ready to do the first test. This is one of the dummy loads for the B plus and B minus output. It's a pair of 3 watt 22K resistors. One resistor between ground and one between ground and B minus, and one between ground and B plus. And then for the plus and minus 15 circuit, there's a pair of 10K quarter watt resistors hooked up in the same fashion. They're actually soldered to the bottom pins on this connector here. Everything is all shown in this diagram in the service manual, and they tell you exactly what to do, even though it's like I said, it's hard to follow because of the English being so messed up on this. power switch input is bypassed, and I'm using an isolation transformer, which is very important. You don't want to be messing with line powered electronics like this without an isolation transformer, unless you absolutely know what you're doing. And I'm supposed to be measuring a waveform on this chip. You know, it's actually the square wave that drives the IGBTs, and you cannot connect the earth ground to the oscilloscope when you're measuring because it can blow the circuit up. And instead of using the scope, I'm going to use my meter with its frequency counter, you know, measurements and things like that. It can do all of them at once, so that should give me my test reading just fine, and I don't have to worry about isolating the earth ground on that. So I won't be able to get this on video because I really have no way of holding the camera and doing this safely because I have to have my hands really close to the circuit board. But I'm going to plug this in and check that waveform, and if that looks good, I'll insert that fuse and test the voltage at the output terminals. Hopefully this thing is going to work because I'm going to be really bummed if it doesn't. Well, so far so good. The 15-volt regulator is working perfectly, and I have a waveform coming out of that chip like I should. So that's very promising. I've got that fuse installed now, and I'm going to turn the board back upside down and plug it in and test the actual output voltages. And one of the reasons I'm turning it back upside down is if something is going to blow up, I would rather not get hit in the face with it, so it's best to work on it facing the other way. I don't like having capacitors like this or big transistors explode in my face. It's not fun, so we're going to take a precaution. Well, it seems to be working just fine. In fact, I've had it unplugged for a couple minutes, and I still have 160 volts DC on this bank of filter caps, so obviously you want to discharge those before you handle the board. And it talks about that in the service manual as well, on how to discharge all the caps and make sure it's safe for handling. Obviously don't try to use my video to try to fix one of these yourself. Get the service manual and read it, and you know, do what it tells you to do. Maybe use the video for a guide, because this isn't meant to be an instructional video. It's more of, hey, I'm working on this, check this out, you know, watch me fix it basically, but it's not meant to be a set of instructions in any way. A couple other notes on this. These two resistors over here that are supposed to be ceramic that I changed out for these little wire-wound silicon ones. Normally I don't recommend doing something like that because they're ceramic for a reason. It's a safety concern actually. I think these ceramic ones prevent flame-ups if those burn out. In fact, you can see just how hot these were at one time. But this is just something in my personal collection, and I did put quite a bit of effort into finding the proper resistors. Those I'm going to have to do for now, and maybe in the future I will change those. Also, on the back of this board, I noticed that they did not trim a lot of the leads enough, and a lot of them they stick out really far, and they tend to bend over, and some of them will touch each other if they get bent in the right direction. And you definitely want to go through and clip them off or straighten them out, make sure nothing is touching before you reinstall this board. The whole thing is like that, so definitely something you want to watch out for. Don't want any shorts. There's residue all over this board from the flux remover. I'm not sure why it does that, but it's hard for me to wipe the normally I brush the flux remover on and then wipe it off with the rag, but it's hard to wipe it with the rag when all the leads are sticking out like that, so gotta do the best I can do. Alright, board's reinstalled and everything's connected. Make darn sure you've got the power connectors in the right spot. They are color coded and labeled on the board, but just double check all that. I've also checked to make sure there's no shorts between these terminals, indicating a shorted output module, because I don't want to blow this power supply up again. But who knows what's going to happen. When I push this switch, there should be a slight delay, and then hopefully it'll turn on normally. But this is the first time I've ever turned it on, so hopefully nothing's going to pop in my face. Here we go. Oh, I saw some smoke. That was weird. I wonder what smoked. Power's on, but the fans aren't running. Oh, maybe they don't need to run, but nonetheless. I wonder what put off that little whiff of smoke. Maybe it was those 2 resistors. That was strange. Let me look into this some more. Well, you know what? At this point, I don't really care. I'm going to hook speakers and a source up to this and see what it does. I think that brief puff of smoke was actually those 2 resistors that I changed down there with the wrong type. So I do need to get the ceramic ones for that. But let's see what happens if I connect this thing up and try to run it. At this point, it doesn't really matter. I'm just experimenting with it, so if it works, cool. Wow, this thing sounds good so far. Apparently the fans are thermally controlled because they just twitch once in a while. They'll probably start running when he heats up. Well, I guess I gotta get the right resistors for those 2 down there, and other than that, take care of the output modules when I get time. But for now, I'm gonna push this aside, test it a while, and finish it up at a later date. I just wanted to get the thing running. Well, I've been beating the crap out of it with trance and dubstep for the past half hour, and it hardly flinches. The fans are still not running, and it's not even warm. Pretty crazy. Must be a pretty efficient design. But I thought I'd make a quick comment on how this setup works. This EQ is basically being used to go between the computer and the amp, or whatever else I'm working on, because it has a limiter. I can bypass the EQ, or I can adjust the level. So it basically allows me to use the unbalanced output off the computer into here, and then this can put out a balanced output into whatever I'm testing, so I can use it to its full potential and test the differential amplifiers and things like that on the input boards. The really nice thing about these boards with the Realtek chipset on board for the audio, you can retest the connectors. So I have the blue connector, which is normally a line in. I retest it to be line out. So I still have the green plug for this amp. I'm just using the computer like normal. And I can use the blue plug to go over to that EQ and limiter to test whatever I'm doing on the bench without interfering with the main speakers. So very, very handy. It's one reason I do like the better Realtek chips on these later boards. So but yeah, that's pretty much it. I might do a follow-up on this amp sometime in the future, but I want to move on to the Crest amp that's next in line, so stay tuned for that.